Imagine waking up one morning, only to discover your body is no longer obeying you. Every step you take, every direction you turn is controlled by something else. It sounds like science fiction, but deep inside tropical rainforests, this happens every single day, not to humans, but to ants. A tiny fungus hijacks their bodies, turning them into spore factories. So how can a fungus control an animal without having a brain? Everything begins with a single microscopic spore, floating silently. Through the humid rainforest, the spore lands on an unsuspecting ant. The ant doesn't notice. The spore sticks to its hard shell. Then, it begins to grow. Tiny fungal threads produce enzymes, slowly breaking through the ant's protective exoskeleton. The invasion has begun. Within days, the fungus has entered the ant's body, multiplying rapidly. Inside the ant, the fungus spreads, absorbing nutrients from within. It grows thread-like cells. Surprisingly, the ant continues living almost normally. It still walks, still works, and still interacts with other ants. From the outside, nothing seems wrong. But the fungus is taking over.
Then, something extraordinary happens. The ant suddenly leaves its colony.
It begins climbing nearby plants, going higher and higher. Ignoring food, ignoring nestmates, ignoring everything it once did. Scientists believe the fungus releases chemicals that interfere with behavior. Exactly how this happens is still being actively investigated. But one thing is certain, the ant is climbing upward, to a place it would never choose on its own. Eventually, the ant reaches the perfect height, under a leaf. Then, it bites down with incredible, desperate force. The jaws lock tightly onto the main leaf vein. Scientists call this final act the death grip. The muscles become permanently fixed, freezing the ant in place. Even after the ant dies, its body remains strongly attached, exactly where the fungus needs it for its next phase. With the ant no longer alive, the fungus begins its final stage. It grows through the body, absorbing the last remaining tissues, eventually producing a long stalk that emerges from the head. At the tip of this stalk, a capsule forms. Inside the capsule, thousands of new spores mature slowly, waiting patiently for the perfect, humid, and wet moment. When humidity and temperature are just right, the capsule bursts. Millions of microscopic spores drift downward like invisible rain. Below, healthy ants continue walking through the forest floors, completely unaware that lethal danger is falling from above. One spore is enough, and the cycle begins again. But the ants have not surrendered to this threat.
Some species detect infected colony members very quickly.
Workers carry sick ants far away from the nest. Others remove dangerous fungal spores before they can spread. Some colonies even change where they forage to avoid danger. For millions of years, they've been locked in an arms race. Every new fungal strategy is met by a new ant defense.
Neither side ever truly wins this eternal struggle. Researchers continue studying this fungus for an important reason. Understanding how it communicates with cells may help brain chemistry. It might even lead to the discovery of new medicines. The fungus doesn't control every insect, posing no human threat. But it demonstrates how simple organisms evolve complex survival strategies.
Deep inside the rainforest, this drama continues every single day. Microscopic spore lands. An ant begins to climb. A leaf becomes the final destination. And a new generation of spores enters the air. No monster, no predator, just a fungus, following the only strategy evolution ever asked of it. Because sometimes, the most terrifying hunter in nature doesn't have claws, or teeth, or even a brain. It only needs a single spore